So we are looking at trimmed mean. So as to find the mean by removing the extreme highs and extreme lows. Usually a 5% trimmed mean is used. This implies that we trim the lowest 5% of the data as well as the highest 5% of the data. Similar procedure is used for a 10% trim. 10% means highest 10% and lowest 10%. Get rid of it. But let's look at what is 5% trimmed mean. Order the data from smallest to largest. Delete the bottom 5% of the data and the top 5% of the data. If the calculations of 5% of the data numbers does not produce a whole number, round to the nearest integer. Okay. Compute the mean of the remaining 90%. Okay. In general, when a data distribution is mound shaped, symmetrical, the values for mean, median, and mode are same or almost the same. For skewed left distributions, the mean is less than the median and the median is less than the mode. For skewed right distributions, the mode is the smallest value, the median is the next largest, and mean is the largest. Let's see the pictures. Okay, so this is more or less symmetric. Mean, median, and mode, they more or less align. Okay, now let's close. This is skewed left. Notice the tail is to the left. So the median is somewhere here. The mode is to the right and mean is to the left. Okay, so there, because it was even, they agreed. Here we are skewed left, so mean is left, median is in the middle, and mode is to the right. Okay, mode will always have the highest frequency, so you're following the mode. Okay, now let's see here. Skewed right, so the tail is to the right. Mode is the one with the highest frequency. Mean is skewed to the right and median is between the two. So basically median is always between mode and mean. Mode follows the highest and then mean goes towards the tail. All right. Next, weighted average. Okay, this is something you're familiar with, I'm sure. When you look at your scores, there is so-called weighted average. What does that mean? Sometimes we wish to average numbers, but we want to assign more importance or weight to some of the numbers. For instance, suppose your professor tells you that your grade will be based on midterm and final exam, each of which is based on 100 possible points. However, the final exam will be worth 60% of the grade and midterm only 40%. So you see, both midterm and final are of 100 points each, but final exam is weighted more than the midterm exam. How could you determine an average score that would reflect these different weights? So here is your formula. Weighted average. Your score times the weight. Add such things. Divide by sum, add all the weights. Okay, so instead of dividing by the total number, you are dividing by the sum of the weights. Upstairs, instead of simply adding the scores, you are adding score times weight. So X is the data value, W is the weight assigned to that data value. Sum is taken over all data values. So how do you read this? Weighted average is summation X times W over summation W. Alright, summation means you are adding X values with the respective weight, and when you are dividing by the addition of all the or sum of all the weights. So let's look at a concrete example. Your midterm is 83, final exam is 95. Now remember, midterm the weight was 40%, final the weight is 60%. So minimum average for an A is 90. Will you get an A? So look, final you got 95, midterm you got 83. So now let's compute the weighted average. Weighted average, midterm times 0.40 because that's 40%. 40% means 40 over 100. So that's 0.40 plus final exam times 60%. 60% is 0.60. 0.40 plus, so these are the weights. So remember, you were given weights in percentages. Don't forget to convert them to numbers. All right. So 0.4 plus 0.6 is 1. That's fine. Upstairs you add them, you get 90.2. So basically you get an A. You barely make it. Across 90, you get an A. Okay. So that completes our slides for section 3.1. Next videos will cover problems on section 3.1. Until then, bye.